Welcome to our lesson on molarity. Molarity is just one way of expressing the concentration of solutions. In this lesson, we're going to learn how to do molarity calculations and make a solution of a certain molarity. And of course, we're going to answer the following questions. What is concentration? How is molarity expressed? And how is molarity used in calculations? But before we go to answering the questions on what is concentration, let's try to have a review of what we have learned in the previous week, which is all about solution. We have learned that solution is a mixture of a solvent and a solute. So if we add solute into a certain solvent, like for example, in this beaker of water here, we have the solute. Let's say these particles right here are, let's say they are the particles of sugar. And of course, we have here the water. Okay. So this is the H2O. So when we combine this solute, sugar, and the water together, they form a mixture of solute and a solvent, which we call sugar solution. That's how solution is made. And when we say concentration, that depends on the amount of sugar that you put on the solvent water. For example, we have put sugar in a beaker of water. If we have a lower concentration, of course, there's less amount of solute that is added to the solvent. And if you have greater concentration of sugar, we say that is higher concentrated. Okay, so because there's more particles of the sugar solute in the water. And that is how concentration is measured. How much of the substance is dissolved in a given amount of solvent. We'll be using this concentration in other ways of learning how to express concentrations of solutions. And the first question that we have, what is molarity? Okay, so molarity, as I have said, is one way of expressing the concentration of solution, and it is defined as the number of moles of a compound dissolved in an amount of solvent, which is usually the water. It can be solved by the following equation. So molarity, the moles of solute divided by the liters of solution. So when we say liters of solution, of course, that's including our solute and our solvent. So solute plus solvent. So we got to add the amount of solute plus the amount of solvent to get the liters of the solution. Because what makes up a solution is the solute and, of course, the solvent. Okay. And you have to be aware that the number of moles of a solute can be calculated as mass over a molar mass, which and we have discussed calculating the molar mass before when doing the stoichiometry. So if the given is mass, you need to convert the mass into number of moles by dividing mass to its molar mass. Okay, so that's how you calculate the number of moles of the solute. Okay, so we have here, if we're looking for moles of solute, it's gonna be equal to, you have to multiply molarity times liter of solution. So there's gonna be molarity over liter of solution. Okay, and of course, if you're looking for liters of solution, so there's gonna be liter of solution. That's gonna be moles solute divided by molarity. Okay. By the way, if you're going to use symbols, moles is identified by the symbol N, and molarity is M. Okay, and then liters of solution is the volume, so M over V. Okay. All right, let's define more molarity. Okay, by looking at this video.
A 1.36 molar glucose solution contains 1.36 moles of glucose in 1 cubic decimeter of the solution. A 0.22 molar urea solution contains 0.22 moles of urea in 1 cubic decimeter of the solution. Let us consider 1 cubic decimeter of a 1.36 molar glucose solution. We remove half of the solution. As a result, we now have 0.5 cubic decimeters of this solution, containing 0.68 moles. So its concentration is also 1.36 moles per cubic decimeter. Note that the number of moles of solute depends on the size of the sample of solution and is equal to the product of molarity and the volume of the sample of solution. In contrast, molarity does not depend on the size of the sample of solution. Let us use an example from the kitchen. If you drink some tea, you know that its sweetness will be the same whether you take only a few drops or gulp the tea from a large mug. However, the amount of sugar you drink in your tea depends both on how sweet the tea is and on the amount of tea you actually drink. Molarity is expressed in moles per cubic decimeter. A 1 molar solution of glucose or urea is a solution that contains 1 mole of glucose or urea in 1 cubic decimeter of the solution.
Okay, this means that 1 liter is equal to 1 cubic decimeter. So if you see that unit, one cubic decimeter, then that is equal to 1 liter of the solution, which is what we need. Okay, so basing from our definition, we have molarity equals the mole of solute divided by the liters of solution. So this is equal to M equals N over V. Okay. Okay. How is molarity expressed? Of course, basing from what you have seen in our video, molarity is the measure of concentration. So we have moles of solute divided by the liter of solution, which is expressed as mole divided by liter. Okay, so if we have 1.25 molarity of KCl solution, which means we have 1.25 mole of KCl per liter of KCl solution. So when it's an aqueous solution, it's actually made up of water solvent. So we have 1.25 mole per liter of that solution. So I repeat, if we have 1.25 molarity KCl, there's 1.25 mole of KCl in every liter of that solution. So let's take, for example, this one right here. So which is more concentrated among these two? We have here 1 molarity solution. So we have 1 molar right here. And then we have 0.5 molar solution of hydrochloric acid, HCl. So which is more concentrated? Of course, the 1 molar is more concentrated than the 0.0 molar solution, because in 1 molar we have 1 mole. So let's say this one right here. This means we have 1 mole KCl per 1 liter of that solution. Okay, and then in here we have 0.5 mole of KCl per 1 liter of solution. Okay, for every liter of solution, we have zero point 0.5 mole of KCl, and for every liter of solution, we have 1 mole of KCl. So, of course, the 1 molar is more concentrated between the two solution. And how to prepare the zero point 0.5 molar solution. Let's say this is the zero point 0.5 molar solution. How are you going to prepare this solution? Okay, so in preparing a zero point 0.5 molar solution, we have to add zero point 0.5 mole of solute to 1 liter volumetric flask. So make sure that your flask is actually 1 liter in volume. Okay, and then we're going to put the zero point 0.5 mole of solute in the volumetric flask and then swirl it. Okay, you're going to swirl carefully in order to dissolve the solute. And then after that, you're going to add more water until you reach the 1 liter mark. So for every zero point 0.5 mole of the solute, okay, we have 1 liter of solution. Okay, so you're going to um, fill with water until you reach the 1 liter mark. That's why it's important that your flask is actually 1 liter or more in calibration or in volume. Okay, it can actually accommodate at 1 liter volume. Okay, so our third objective, so we have answered what is concentration, how is molarity expressed, and then we're going to answer question how is molarity used in calculation. Okay, let's have this first problem right here. What is the molarity of a solution containing 0.32 moles of NaCl in 3.4 liters? So before we start plugging our numbers into our calculators, it's good to identify what we're solving for and the other variables in the question. For example, in this problem, we have, of course, we're looking for molarity, okay, which is equal to molarity. Okay, we're looking for molarity. And then, of course, the number of moles, which is N, that's going to be 0.32 moles. And then we have also the volume of solution. So our volume is 3.4 liters. So make sure you look at the units if they are correct. So we need the moles of solute, which is correct. We have the moles. And then the liter of solution. So we have the volume in liter of the solution. Okay. So now we're ready to calculate for molarity. Molarity is equal to moles of solute divided by the volume of solution, which is equal to 0.32 moles, okay, divided by the liter of solution, which is 3.4 liter. Okay, so the 0.32 mole divided by 3.4, that will give you 0.09 molarity. So this is equal to 0.09 molarity. Remember that molarity means moles per liter. So this can also be written as 0.09 mole per liter of solution. Okay, per 1 liter of solution. Okay, that is what is meant by the 0.09 molarity. There's 0.09 mole of the solute, which is NaCl, okay, per liter of solution. Okay, let's take a look at another problem. Okay, let's say, for example, we have here the second problem says, what is the molarity of a solution formed from 6.75 gram of NaCl dissolved in water to make a solution with a total volume of 452 ml. So first thing that you're going to do is to actually identify what is given in the problem. Okay, so what is the molarity? So molarity is what we're looking for. Okay, formed from 6.75 grams. So that means that's the mass, not the mole. Okay, so the mass of is equal to 6.75 grams, and then we have the volume, which is equal to 452 ml. So remember that the unit should be consistent. Okay, so the given is mass, not the number of moles, which we are going to need in our calculation. So how do you get the number of moles? It says here, the number of moles is calculated by dividing the mass to its molar mass, right? So if we're going to calculate the number of moles of this NaCl given the mass 6.75, this should be calculated as, so the mass is 6.75. So we're going to calculate the mole, 6.75 gram divided by the molar mass. When you remember our calculation of molar mass, you have to add all the masses of the element and multiply to the number of atoms. For example, in the formula NaCl, so this is your formula in ACl. There's one atom of Na and one atom of Cl. So that means you are just going to use the mass of Na and Cl in calculating for the molar mass. Let's say, for example, sodium. Okay, so we have sodium is 22.99. As you can see here, we have sodium 22.99 and chlorine is 35.5. So you're going to calculate the molar mass by adding these two atomic masses of the elements. So we have 29.99 plus 35.5, that would give you 65. Okay, so 65, you round that to a whole number. Okay, I would recommend you rounding that to a whole number so that for easy calculations. Okay, so 65.49, that'll give you 65 gram per mole. Okay, you remember molar mass is written as 65 gram per mole. Okay, so this is gonna be 65 gram per mole. Okay, so now you're going to cancel the gram. What you have is the number of mole. So that's gonna be 6.75 divided by 65. You're gonna get 0.10 moles. Okay, so that's gonna be 0.10 mole of NaCl. Okay, and then of course that's our mole. We need to get the volume also, right? So the volume should be in liter. As you can see here, it says liter of solution. Now we have this, we got to get the liter of solution. So the volume is given in milliliters, so we have to convert that into liter. Okay, so the volume, we have 1000 ml equals 1 liter, right? So if we have 452 ml, we got to change that into liter. Okay, so what do? We divide this by 1000. Okay, so 1 liter equals 1000 milliliter. Okay, so cancel milliliter, so you get the liter. Okay, so 452 divided by 1000, so that's gonna give you 0.452 liter. Okay, now we have the mole and we have the liter, which we are going to need for our calculation, right? Okay, so molarity now equals N over V. So the number of mole is 0.10 mole NaCl, and then divided by 0.452 liter. Okay, so we're going to divide this to 0.10 divided by 0.452. That's going to give you 0.22. So 0.22 molarity, or this can also be written as 0.22 mole per liter of solution. Okay, so that's it. We have for every liter of solution, we have 0.22 mole of the solute NaCl. Okay, you only do this type of calculation if the given is mass. As you can see in our first problem, we have already the mole, which is 0.32, and we have the volume in liter. But in our second problem, as you can see, the given is not mole, it's in gram. Okay, so you got to know how to convert the gram into mole by dividing this mass of NaCl to its molar mass. And I teach you, I already told you how to calculate molar mass in our previous lesson before, in stoichiometry, and that is dividing the mass of the compound to its molar mass. And molar mass is calculated by adding the masses of the elements present in a compound. For example, in NaCl, there's one atom of NaCl. That's why you use only once the atomic mass. Okay, and Cl, there's only one in the formula, so you're going to use only once the uh, mass. Okay, it's different, but when you need help, okay, you're going to use the Lentech calculator to calculate for the molar mass. Okay, and I've shown you that before. If you need help, okay, so you're going to Google Lentech calculator. Okay, so we have Lentech calculator, okay, for the molar mass, for molar mass. Okay, and we have used this before, so you should know what you're doing in that Lentech calculator. Okay, okay, let's have additional problem. Calculate the molarity of a solution prepared by mixing 1.5 gram of NaCl in 500 ml of water. Okay, so we have molarity as the unknown variable, and then we have 1.5 gram of NaCl again. So we have our mass is equal to 1.5 gram. Okay, and then we have the volume, which is equal to 500 ml. Okay, remember that we need the moles of the solute, not the mass. Okay, so how do we get the number of moles here? So mole NaCl is equal to mass, which is 1.5, divided by the molar mass of NaCl. Okay, then we use that in problem number 2. The molar mass of NaCl is 65. Okay, 65 gram per mole. All right, so we're going to use that 65 gram per mole divided by 65 gram per mole. So if we cancel gram, we get the mole unit. Okay, so that's gonna give us 1.5 divided by 65, and then that's gonna be 0.02 mole. Okay, okay, 0.02 mole. And of course, the volume also. Now we have the mole of solute. We just need the liter of solution. Okay, so we need the liter of solution. How many liter of solution are there? So let's say 500. We need to convert that into liter, right? Okay, so 500 ml and then 1 liter equals 1000 milliliter. Okay, 0. Okay, so that's gonna give you 500 divided by 1000. So that's gonna give you 0.5. So this is 0.5 liter right there. Okay, so we're ready to calculate for molarity. So molarity is the mole of solute divided by the volume of the solution. So we have 0.02 mole divided by 0.5 liter. Okay, maybe 0.02 mole divided by 0.5. That's gonna give you 0.04 mole per liter, or 0.04 molarity, because molarity means moles per liter of solution. Okay, all right, let's take a look another problem, number 4. Okay, all right, so to make for molarity solution, how many moles of solute will be needed if 12 liters of solution are required? Okay, so you have to identify the given variable. Let's take a look at what is given. So how many moles of solute? So that means we're looking for the number of moles, okay? To make molarity of 4, okay? And then we also have the volume, which is 12.0 liters, okay? So remember that this is your equation for molarity. M equals N over V. So if we're looking for the number of moles, of course, we got to multiply M times V. So that's going to be molarity times volume. Okay, so our molarity is 4.00. In order to facilitate the cancellation of units, you have to put what is meant by molarity, which is mole per liter of solution, times the volume, which is 12.0 liter. So that you can see, okay, cancel liter and then cancel the liter right here, so that your unit will be mole. So 4.00 times 12, that's gonna give you 48. Okay, so 48 mole of that solute. Okay, so that means you need 48 mole of that solute, and then add water to make a 12-liter solution. That is how you're going to prepare the 4 molarity solution. Okay, so let's say, for example, here, this is a beaker of water. Okay, and then you got to put 4 moles, 4.00 mole of solute. Okay, and then of course you have to make sure that your volume is actually 12 liters right there. 12 liters. Okay, that would make up a 4 molarity solution. Okay, all right, let's have another problem. Okay, all right, calculating the liters of solution that can be produced from 2.5 moles of solute. So we have the number of moles, which is 2.5. So N is equal to 2.5 moles. And then we have a volume of solution, which is unknown. So that's what we're looking for. Okay. and then the molarity, which is 2.0 molarity. Okay, we're looking to find the volume. So basing from our equation, if you're looking for volume or the liters of solution, so this is M equals N over V. So if you're looking for volume, that's gonna be N over M. Okay, so volume is equal to the N over M. Okay, number of moles divided by molarity. So the number of moles is 2.5 divided by molarity, which is 2.0. Let's say a mole per liter, because that is what is meant by molarity, the big M. That's mole per liter. So you cancel the mole to get the liter as your unit. Okay. So we have 2.5 divided by 2.0. That's going to give you 1.25. So this is going to be 1.25 liter of solution, which is the volume. All right, so that's how you express concentrations of solutions using molarity, which is moles per solute divided by the liters of the solution. All right, if you have questions, please send that in my email, or you can chat me and remind whatever questions you have about the lesson. I am always available to answer your questions. As you know, even in the night, I have time to actually answer your questions. Mm. So I would like to thank you all again for your dedication and for your time to actually learn, because never stop learning, because life never stops teaching. So yeah, if you have questions, just let me know. Okay. All right. Bye.